Hello friends, welcome to this video on areas of parallelogram and triangles. In the previous video, we solved some questions related to the area of a triangle and a parallelogram located on the same base and between the same parallel lines. Today, we will discuss some facts related to the area of triangles and parallelograms located on the same base and between the same parallel lines. So let's look at the first question. In the given figure, PQRS is a parallelogram. If VT is equal to 2UV, then what will be the ratio of the areas of quadrilateral PQRS and triangle STR? Can you guess the answer from the following options? Let's see. In the given figure, parallelogram PQRS and triangle STR lie on the same base SR, and we have been given that Vt is equal to 2uv. We can write it like this. Let's consider it as equation 1. We will first find the area of quadrilateral PQRS. Area of a parallelogram is equal to base multiplied by height. Here, base is SR and height is UV. We can place their values in the formula for the area of quadrilateral. We can write it like this using equation 1. By simplifying, we will get, let's call it equation 2. Now let's talk about the area of triangle STR, whose base is SR and height is VT. We know that the area of a triangle is half multiplied by base multiplied by height. Now, we will substitute the values of base and height in this formula. Let's call it equation 3. Now the ratio of the areas of quadrilateral PQRS and triangle STR can be determined by dividing their areas. If solved, their ratio will be 1:1, which is option D. So, we can say that option D is correct. Let's move to the next question. Can the area of a triangle be larger than the area of a parallelogram if they lie between the same parallel lines? Will the answer be yes or no? Pause the video and think of the answer. Friends, to find the answer, we will use the formulas for the area of parallelogram and triangle. First, let's draw a perpendicular from the point G on side EF and call it GH. This is the height of both the triangle and the parallelogram. Since these shapes lie between the parallel lines AD and EF, the height of both will be equal, which is GH. Therefore, their area will depend on their base. The height of both quadrilateral ABCD and triangle EFG is GH. The area of a triangle is half multiplied by base multiplied by height. We can write it as half multiplied by EF multiplied by GH, and the area of a parallelogram is base multiplied by height. We can write it as BC multiplied by GH. If the base of the triangle and the parallelogram are the same, then the area of the triangle will be half the area of the parallelogram. If we increase the size of the base of the triangle 2 times the size of the base of the parallelogram, that is, if EF equals 2BC, then what will happen? Pause the video and think. Area of triangle is equal to half multiplied by 2BC multiplied by GH, which would be BC multiplied by GH. In this case, the area of triangle will be equal to the area of parallelogram. But what will happen if the measurement of the base of the triangle is more than twice the measurement of the base of the quadrilateral? Yes. In this case, the area of the triangle will be more than the area of the quadrilateral. Before we end the video, we have a question for you. If a triangle and a parallelogram are formed on the same base, then can the area of the triangle be larger than the area of the parallelogram? Try to find the answer with the help of this activity. Construct several triangles using the base of the same parallelogram. Try to determine in which case the area of the triangle will be more than the area of the parallelogram. Solve this question with the help of your classmates and teacher. Friends, with this, let us end this session. In this session, we discussed some facts related to the area of parallelograms and triangles located on the same base and between the same parallel lines. See you in the next video. Thank you.